comes to when it comes to 3D printing, it is ideal to have the mesh pose. In this case, the mesh isn't posed. So you could rotate and get all the stuff into position. The main things to look out for in 3D printing are kind of these big cavities and very, very fine parts, things like this, right? Undercuts, so that would be little gaps and cavities that might exist under the print. So a character like this, the neck is very, very thin. Let me just go to auto groups for a second. Right, so each of these, this neck is very, very thin. It wouldn't have enough support on its own to hold that head up. So you would have to exaggerate something like this, for example, and go into inflate to thicken it and exaggerate it so it would hold the head up as a solid print. You ultimately want all your separate mesh pieces to be overlapping and to be able to connect together. So I usually go about it a few ways. One way, like this is one tool, right? Right now, one subtool. So if it's in one subtool, you can actually just try to dynamesh this stuff together. Right, and that would kind of create a solid mesh. Again, I'd probably chop off, or before doing this, ideally separate out the things like that, the little hoodie laces, I guess, is what those are. Again, I might thicken this kind of rope piece or whatever that is. So you do have to kind of consider some of the parts that are going into this and make sure that the mesh and the print can support it. The other thing is with 3D prints, we also have supports that are automatically generated by software. So if you're taking a look at 3D prints, it will generate little additional supports to hold up the print. So anything that, if your print isn't basically like a pyramid, so if it's straight up or has stuff that hangs out over top of the lower portion of the print, it needs to create these supports, because once it starts printing across here, it's printing into thin air, right? It prints layer by layer, slice by slice. And afterwards, you do have to cut this stuff off. So, there is some important considerations to, planning things out. You wind up getting supports at a certain angle. The software will say, okay, I can support this mesh over an extreme angle, an overhang, or this would also be an undercut, right? From looking at it from a base to a top. That's an overhang or an undercut. You'll get these little supports that will have to be cleaned out and scraped out. Okay, so those are things to consider when 3D printing. When export from Maya, the best thing to do is actually, if the character's already rigged in Maya, pose it in Maya, then just select all the mesh components and go to delete history. It'll actually wipe out all the extra rigging components. You can delete all the other components, so save a temp file for that, or a 3D print specific file, and then you can export the character in pose. Now I'll use a couple of examples that are just built into Zbrush here for some of the things to watch out for. So I mentioned undercuts. There's overhangs and undercuts. Undercuts can be a little bit different. So, or cavities, right? So if we're trying to print something like this guy, classic earthquake, things to watch out for that you want to avoid are these little gaps in between the mesh. So again, I would usually try to make sure this stuff is more flush to the body. So I'm going to just Alt-tap on that kind of bandage and then just try to get it more against the flesh of the character. Other sort of tricks for this, you can hold Alt, which will pull out, pull that mesh out. So I usually use just a regular move brush to get this against the surface, and then hold Alt to move any part that might be sticking out. Another kind of quick cheat to close the gap on some of these things. And again, there's a slight cavity. It might not be visible right away, but yeah, there's a little bit of a gap there, right, in the bandage and the hand. So we don't want to leave a cavity like that in the print. It can cause all kinds of errors. So sometimes what I'll do is I'll inflate, smooth and inflate to get that bandage to kind of just sit more up against that fleshy part of the character. So again, you want to have, you're going to have to go through and kind of analyze those parts of your model to make sure you're not going to have any issues during print. Same thing with the back of this character's vest, for example. It's really hanging off. You can, in fact, print this way, but again, it gets really problematic when you have very, very thin mesh like this, like the jacket. It can be very fragile. So ideally, I recommend inflating or bridging the gap between these two pieces. So the question is, do we want it high poly or low poly? If you want the character to look ultra low poly, then keep it ultra low poly. But when it comes to a 3D print, it's probably going to look better smooth. So I would definitely, before dynameshing or using booleans to combine these parts together, I would suggest thinking about smoothing the mesh first. Now you can also try another little tool. I didn't use it earlier, but there's something called Matchmaker, which will try to shrink wrap. B for brush, M for Matchmaker. And it literally will try to match the current subtool against the next subtool. It's based on camera angle. And you can see it's actually pulling in the pants as well. I'm going to hide the pants for a minute. I'll turn off color as well. So, and I'll also adjust my Z intensity down a bit. But if you take a look, it's going to try to really form that mesh. So it's almost like a projection brush. So that might help pull that stuff against the, the body. And then you could also, as a bit of a trick, just go into deformation. Again, this is a very worst case sort of scenario. You can also just try and go and inflate that particular jacket a bit. Right, so it's a little chunkier than it normally would be. Again, it might require some custom sculpting, and I'd probably, in areas where, again, there's kind of a cavity, this is an undercut and a cavity, we want to try to sort of seal that off. So I would take a large brush and just try to lay it a little bit flatter against that little area there. This one might be harder to avoid, but again, I might just try to, alter this as much as I can. So get as much of that, connected to the main part of the print. There are prints that have very, very intricate and detailed clothing like this that are swinging off the body and have ribbons, but we're doing very kind of simplified prints. So I want to have you guys set your stuff up for ease of printing, and I don't want to be troubleshooting your prints. I'll just, if I have problems with your prints, I'll literally just send them back to you and tell you to figure it out. But things like these little straps, again, they're going to be so fragile and small. I would either slice off the extra bits that are not visible, right? So we could actually just go to slice curve and just slice off that extra bit. Or I would just say we can probably delete them entirely from the sculpt. Now let's put his pants back on. Okay. So even like this gap in the pants, I would say, it might be easier to just seal up the rips in the pants, or, maybe bring the knees forward enough so that it kind of just meets the rip in the pants. So I'd hold Alt. Alt is going to pull the mesh forward in the direction that the vertex is already facing, and then I would, with a smaller brush, hold Alt again and just tuck back the parts that are kind of leaping through. So we can try to marry the two surfaces a little bit kind of closer together, if that makes sense. Okay, so we'll try to push some of this stuff back and in. So, you have to go through the rest of the character mesh and really try your best to avoid these sort of smaller cavities. I'm not going to finish with this character just because there's a lot of work that would still be left to do. So if you take a look, there's actually tiny little cavities even around the teeth. So you would have to go into kind of the teeth and maybe overinflate them a bit, or even put in, if we just hide them for a minute, right? You might even have to put in a little filler cavity right behind the teeth, like a sphere or something, to kind of block off that hole, because we don't want that to be a cavity inside that then has supports and leaves all sorts of mess. So, one quick and cheap and dirty technique that works is to actually just try to overinflate until the cavities are kind of gone. So I'm going to just try to inflate that. Now his gums do poke through a little bit as a result of that. So again, I can just use the move brush up here and just kind of push just that stuff that's peeking through back in. So even that little stray tooth I'll poke back in. So that would be a quick and simple fix. Now the other thing is you have to keep in mind this thing is going to be printed in grayscale. There's going to be no color except for whatever color the spool is in. So probably good to just see this with poly paint. So next up, what I recommend in terms of processing is definitely I usually put a pedestal on here. So I put a disc of some kind, a cylinder. And I'd make sure, again, there's no gap between the pedestal and the foot. So for that, I'll just go to Subtool, Append, Cylinder. I'm going to select that cylinder, squash it down. Doesn't need to be anything too elaborate, but just something that'll kind of hold the model in place. So I'm okay to kind of cut off a bit of the foot. Again, I want enough overlap so that I don't have any problems with this kind of adhering to that surface. So I may just adjust the centering over here as well. Now, one thing I will mention is, generally speaking, I don't like segmented mesh. I don't want things to look low poly in my model. So if I'm going to adjust the base, for example, I might just go into ZModeler and maybe delete some. I'll delete some of the loops I don't really care for. So let's get rid of a bunch of these. You can even taper things. You can give this a different shape. You can sculpt it as well. Sometimes it's interesting to use an environment mesh that you have from your film, maybe as a piece. You can slice off a chunk and put it in here. And I'll go to bevel. I'll bevel this loop up here. And then I like to go in and use crease. It's a very quick way to kind of add a little bit of sharpness. And I like controlling crease by setting the crease level. So I'm going to set this to a level 2. And what that's going to mean, I'll show you in a second. If I hit crease polygroup, it's going to just crease along the two groups there. And I think I'm going to force it to, I'm going to force a crease down here as well. So I'm going to just go crease with my ZModeler. So what that means is at level 2, it's going to hold the crease. If I divide this once, divide it twice, it'll keep that crease. And then over level 2, it starts to round out a little bit. So you get a little bit of kind of softening across that edge, which is nice. So as I said, in a situation where you have the tools all connected, touching, overlapping, what you want to do, I usually, my first step is to then activate Boolean. So whatever your largest piece is, which might be the body or the main torso or the main kind of largest chunk of mesh, which in this case is the body. I'm going to leave this, turn on this little arrow option, which is the Boolean option, and hit Live Boolean. Now, right now, it's not going to change anything. But if I go down into the Boolean menu and hit Make Boolean Mesh, it will essentially combine all the tools. Wherever the overlap is, it'll connect and merge them. So it'll become a solid, hopefully, a solid single shell for the whole character mesh. That single shell becomes a separate tool over here. So this is the current tool I'm on. And then if I go to U-Mesh, it's now just a single solid subtool. If you hit Shift F, you'll see, right, wherever there's more mesh and less mesh and where they overlap, it's going to try to connect all that stuff. So one final step I find that can also help if there are any gaps that you still discover. Like I think there's still a gap here, so I'm going to just try to move this stuff down. So again, there's still some heavy undercuts in here, so I'm going to just try to hopefully inflate my way through this. You can also use your move brush as well, right, to try to bring this down. So once I have a Boolean mesh, I will kind of dynamesh at a certain point. So when I dynamesh, I always try to match roughly my resolution to what I have. Sometimes I'll go a bit higher, sometimes a bit lower. If I go higher, it's mainly because I feel like I may be losing some detail in some way, but I'm going to just hit Dynamesh. And this will also, in addition to the Boolean step, so the Boolean step I find it helps unify the mesh. The Dynamesh helps to kind of clear out any excess overlap and allow you to kind of go through and do any final fixes that you need to do on the model. Now, there are some issues. Now, this thing did Dynamesh at a bit of a low res, but I'm going to just kind of push ahead for demo's sake. So again, I would say, let's pretend this is higher res. If you do still see some weird little cavities, then I would just inflate those little error-prone areas and Dynamesh again. Right, so just folding over and dynameshing will fix some of those little troublesome cavities. Now again, this is a little bit lower res than I intended to be, but this would be a good way to kind of show you some of the errors that can pop up too. So remember the cavity I was talking about between the leg and the pants? If that happens, okay. So yeah, if you get the Swiss cheese effect again, just kind of inflating a bit and closing off the excess cavities can help. Now again, I'd have more detail than this, but I'll just re-dynamesh, and this should hopefully kind of help heal this out a bit. So as I inflate, this stuff kind of goes away, and then you can do touch-up sculpting if you need to. Yeah, ideally, your character would be a little bit more simplified than this sculpt, but I will just kind of proceed to show you one of my final steps. So if you're happy with that result, right, the mesh, it's not too dense at 1,000,000 polys, but I find for then doing the final step of processing, I do like to decimate the character. So my first step is, whether you bring it in from Maya or it's still in Zbrush and a bunch of tools, I boolean together the mesh first, and I sort of do all my major fixes before the boolean. Once I have a boolean mesh, I then dynamesh it to really get a solid shell mesh and to really work out any of those smaller, finer issues. Then I decimate, so that's the third step, to process the mesh and make it ultra light and efficient for the final step of 3D printing. So I go to Z plugin, decimation master. So what I'm going to do is just hit pre-process the current tool. So what it does is it goes through and analyze areas of high detail, and it'll concentrate triangles and vertices in those areas. And areas where there's low detail, it'll basically pull out as many vertices and polygons and basically create low triangulation areas. So for 3D printing, I usually go between 250,000 and 500,000 point count. So you have to process the subtool first, and then you have to go back in and hit decimate. So I usually go to the preset of 250,000 for print purposes. You can go lower if you want to do something like set up this for doing like new topology with CrawDraw or whatever, right? You can go by percentage as well. So you could say I want to go, 13% is about 250,000 polys. This is in thousands of polys, so this is 250,000. You go a bit higher, right? That's going to be closer to 500,000, but I'm going to pick the preset 250K. And you can see, right, really strips out polys in areas where they're not needed and focuses them on where they are needed. And what's great about this is that if you undo and redo, right, you can hardly tell a difference in the sort of shape, in the surface detail. And so for me, that's one of the final steps before getting ready to print. The last step, which is going to be the last step that I'm going to ask you guys to produce for me, is to go into 3D Prints, 3D Print Hub. And right now, I think by default, it's around 2.5 centimeters or 25 millimeters. 3D print objects are recorded. Their data is recorded in millimeters always. So if you're working in centimeters, inches, or something else, like ZBrush by default works in centimeters, Maya works by default in centimeters. So in your head, you're going to have to multiply by 10, except for when you get here. So I usually like to set this to around 5 centimeters. So I go update ratio and click on this ratio of 50, 52, 55, 50 millimeters. So it's going to actually go in and update this scale so that when I export the file, and before exporting, actually one final step to do is to check the mesh for errors. So this mesh contains 6 faces with multiple references to the same vertex. So I'm going to also a ton of edge issues because I think there's still some issues in the pants. So I'm going to just tell it to try to fix that for me. And I may also do optimize points. So if you don't have my interface loaded, you can always find that under geometry, mesh integrity, check mesh, fix mesh, and then modify topology, optimize points. So that's a good final step before you do your actual export. And then I just simply want to go export to STL. I'm going to just save this on my D drive, save it out. Now, like I said, the software you're using will be different. I'm using a Zortrax M300. So I'm going to click on this. I'm using the Z Suite software. And most 3D software, 3D print software that comes with or is recommended by a print manufacturer will take you through roughly the same steps. So I'll just kind of discuss these in brief. So I'm going to import the mesh. Usually it'll find and automatically fix errors. Some software will allow you to analyze the software and then manually sculpt out some errors. In this case, I think it's going to try to do its best to basically fix those. Again, I usually like to try to do that during the Boolean or subtool Boolean Dynamesh process. That's where I'm really trying to, manually and by myself fix those errors in printing. So the print will come in kind of on its back, I find, usually. So I can select the prints. I'm going to go into rotate and rotate this thing 90 degrees. Now this print volume, by the way, this is the full printer surface. Our printer can print a full cubic foot, so a full 30 centimeters cubed. So this thing could go up to, if we were to take its size here, resize. And we should, make sure that this is all connected together. I could try to go up to the max. I'll go to like 290, right? So I could print almost that big, right, if I wanted to. But for you guys, when we start printing, we're going to print prototypes. So I'm going to ask for about 5 centimeter tall prints. So I'll have you do a bunch of them. I'll print a bunch at once. So I'll have a whole bunch loaded in here. And whatever works well, great. Anything that needs fixing, I'll send back to you for you to fix. But let's just go through the rest of the process. So basically, we're going to go into print settings. So what we have is this thing called the infill density. So that is actually a pattern that, so instead of the mesh being printed in solid plastic, it actually gets a certain thickness to the outside shell of the mesh. And then inside, it gets a hollow pattern printed inside of it. So it makes it ultra strong and ultra light. There are certain materials that we have here. There's Z-Hips, PETG, PLA, ASA. Some of these plastics, I believe PETG is actually very, very similar to Lego plastic, and that's one of the two types of materials we have. We have Z-Hip and PETG. So depending on the material you have, it will allow you sometimes more fine-tuned printing. So some materials allow for ultra-fine printing, and other materials like the PETG is a little bit rougher. This is the layer thickness. Now, in advanced settings, I usually do go into advanced settings. I have supports that will be generated. I like them to be light so that they're very easy. They can almost be snapped off by hand with very little, knife and sharp tools. So I'll set this to light, make them editable so that when they're generated, I can cut them as I want. I usually choose a honeycomb infill, and 10% or 20% for me is okay for the infill. That's the mesh inside. So again, we're wasting less plastic and we're keeping it light and strong. So I'll click on support, which brings me to the support level. So it's going to go through prep the model for print. And let me zoom in if I can. So I'm going to turn on light for the print and hit generate, and you're going to see some little supports. They're going to look like little white pegs. So they'll come up from the base to the arms. It's also going to print what's called a raft. So you'll see a bigger disc beyond that base disc that's there. That allows the print to stick to the print bed, which is also very important. We want the print to actually hold onto the print bed as it moves around and prints. We don't want it to melt and shift off. But we also want to be able to release the print after it's done. So that raft, it's called, is like wherever the attachment points of the print are, is where it prints this extra kind of pattern. So that allows you to kind of easily scrape the print off the print bed once the job is done. Okay, so you can, if the supports are editable, you can select them and delete them if you find they're a bit excessive. I usually don't mess with this too much. I generally will let the software do its thing. There might be a couple here and there that I decide, I don't need, or I'll take a chance and avoid. But in this case, I'm just going to proceed with the preview here. So the final step is that the model needs to be sliced into horizontal slices, because that's how the printer is going to print. It's going to basically lay down like an outline of plastic and then lay down another layer and build up the model that way from the bottom up. So the software will always have to kind of do this layer slicing. And usually that slicing is dependent on, again, the fineness of the printer, how fine of a resolution can it print, which means how fine can the slices be, and also that's also partially dictated by the plastics that are used or the materials that are used for print. Right, so the idea is that once it's done the slicing, if you take a look, right, the software has to kind of pre-slice. Now the mesh will not look as rough as it does in this preview, at least in this software. But you can sort of see the honeycomb effect that is carried through the mesh, right? So the software has to kind of have an idea of what the printer is going to get. The printer needs to know what the layers and approximate slices are for it to print accurately. And as I said, this little disc at the bottom is the raft, so that's going to allow you to take the print off the print bed pretty easily. Now this particular printer and software requires a file to be exported. I'm going to take care of that, but has its own specific Z code format. I think there are different types of Z code. There's different print software out there. So this particular printer, you have to load the Z code onto literally a little mini SD, micro SD stick that then goes into the printer. Then you pick the file and print it. Normally there's calibration that is needed. So you have to heat up the print bed, heat up the print nozzle. The nozzle has to be clean. The bed has to be level. But ultimately, if you've gone through your ZBrush steps properly, the rest should be a fair bit easier. So as I was mentioning, you can actually verify your prints in here as well. Sometimes that can be useful to just make sure your STLs are fine. So sometimes it will go back to ZBrush if I notice there's a ton of little errors. There's a little analysis button in here that you can use. Now I don't necessarily export from here to my print software, but there are ways to actually have this be another step in your pipeline where you go from ZBrush then back out. So yeah, a lot of the issues I think, which I realized were probably going to be here, are this kind of weird overlap between the legs and the pants. So I think there'd be a little bit more kind of filling of the mesh. So you can try to analyze for thickness or use Inspector is actually the main one that's going to kind of find the errors, and you can have it actually auto repair this with flat fill or a smooth fill. I would say, since this is more of a sculptural piece, I would say probably smooth would be a better option. So you can then re-export this STL back out before sending it to me or to your print software. So that sort of does some quick patching of the model. For me, I would just look at this color coding to then go back to ZBrush and do a touch-up sculpt and re-dynamesh the problem spots.